tomorrow will be better. Show that the pressure of a liquid at the bottom of its container is P equals the density times the gravitational acceleration times the height of the liquid. Follow me, dear friends. Solution. Now, to better solve this, let us try to put down a diagram that represents the situation in question. Here is a rectangular tank with a rectangular bottom, and the water column is, say, H. Now, let's start by writing the expression for pressure, okay? Pressure generally is given by the expression force over area, is a force per unit area. But in this particular case of a liquid which is resting, I repeat, which is resting in a container like this, in the absence of any other external force, the only force acting at the bottom here of this rectangular base is the weight of the liquid which is above it, okay? And we know that weight is given by mg. So this force here will be given by mg. Now let us further simplify this. It means the expression P will boil down to mg divided by A. But we are having an expression to prove here, so this is where our target should be. We can further express m. From the expression, density is equal to the mass per unit volume of a substance. From here, m can be expressed as, if you cross multiply, you have that m is going to be the density times the volume here. So if I replace this here, I'm going to have that P now becomes rho, the volume, times gravitational acceleration, all divided by A. But since I've assumed for simplicity's sake that my container has a rectangular base, what is the area? Area of the base. What is the base area? Base area will be given by the length times the width. Okay? And now if I have to calculate the volume of water in this rectangular container, I'm going to have that. But volume is equal to the base area, which I already have here, A times B, now times the height of the water column, okay, times the height, H. Now, everything here is going to boil down to something interesting. Look at it. P, therefore, we make the statement, therefore, or this implies that P is going to be equal to the density first, times the volume of water of the container, which is the base area first, and then times the water column, H, and now times the gravitational acceleration, all divided by the base area, A. Okay, A times B. Why are we getting the base area here? Because this water is acting on this surface, and the area in question is the area of the surface on which it is acting, and the surface is a rectangular surface. So this is how we get it. Base area cancels base area. This means pressure will boil down to rho times G and then times H, because tomorrow will be better.